Okay, so let's do a quick walkthrough of the Spring 2020 Foundations midterm. So this first section is all about subset, and you have to be a set to be a subset. So that one, right? A is not a subset, B is not a subset, AC, these guys are all not subsets because they're not sets. So these automatically get no, 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 no. The empty set is a subset of everything, so that gets yes. Um, and then remember, a subset has all of the elements in this set have to be in this set. And I look in here, and it only has, in here it only has one element A, and there's also an A in this set, so the answer is yes. And this next set here is just a B. And while there are some strings that have B inside of this set, there's no string that's just B. And so the answer to this one is no. Now we're looking for the string AC in here. And while I do see AC in there, it's not just the string AC, it's the set containing the string AC. So the answer is no. And then we look at this next set, and there's two elements in there. The first one is an A, and that definitely appears in the set. The second one is the string BC, and that also appears in my set. And that's all of the elements in here appear in here, so it is indeed a subset. So if we move up to the second thing, now we're talking about element. Is this an element of the set, right? So do we find, oops, sorry, there we go. Is the empty set actually found in this list? And the answer is yeah, it's right there. It's an element. So yes, it's an element. Is the letter A an element? Yep, there it is. So yes. Is the letter B an element? Well, no, we saw last time. It's not. Nope. Is the string AC an element? Again, no, there's no AC in there. There's a set that contains AC, but there's no just plain old AC, so the answer is no. Is ABC an element? Yeah, well, there's the string ABC, so we get yes. Is the set containing A an element? Well, there's an A here, but no set containing A, so the answer is no. Is the set containing B an element? Same thing, no. But what about the set containing AC? Well, yeah, absolutely. The set containing AC is an element, so we say yes. And what about the set containing A and BC? Well, A and BC are both elements of this big set, but we don't want to see if A and BC are elements. We want to see whether this set containing both of them is an element. And that is not, so we say no. Okay, for this section, I need to write the item numbers from the list given for my answer, right? And I have an example here. It says list all the items that are elements of this set, and the elements of this set are just the single string or the single element A. I suppose it's also a string, right? A, B by itself, and C by itself. And so we said 8, 9, and 10 because look at that. Where's my pointer? Is that it? Yeah. Ooh, I have a what do you call it? Lightsaber. All right, but you see 8, 9, and 10 are indeed in this set over here. So this first set of questions are about union. This is the set containing A unioned with the set containing A comma B unioned with AB. That actually gives us the set containing, what do we got? We have an A, we have a B, and we have AB, the string. And so now we just look in our list on the right-hand side to see what is in there. And we have an A, so that's item 8. We have a B, so that's item 9. And we look for the AB, right? And the AB is down at item 13. So it's 8, 9, and 13. The next one asks us to list all the elements of this next set. So what do we got? We have A. Oh, it's a bunch of things. It's the same set, right? What a tricky question. Same set, except we're also unioning in with it the empty set. Well, guess what? If we take all of these elements, where are you, lightsaber? If we take all of these guys, and then we add in nothing, we still have the same thing, right? So the answer to this one is also going to be 8, 9, and 13. As we move up a bit, now I need to take a look at this set. So I have A unioned with, where'd you go, lightsaber? A unioned with A comma B, unioned with AB, unioned with the empty set. So I guess the only new thing in here is this AB, right? So now our set actually equals the set. We've got an A, we have a B, and we have an AB. Oh yeah, no, wait a minute. And it says unioned with, and look at that. The teacher was so nice to us, wasn't she? Because up here, she said union with the empty set, and down here, she said union with the set containing the empty set. So it actually makes you look and say, oh yeah, that's the set containing the empty set. Okay. So I guess the other thing in here is going to be the empty set, right? And so now our items are going to be 8, 9, and 13 again, because that's the A, B, and the AB. But we're also putting in the empty set, which is, I believe, item 1. Let's look. Yeah, look all the way up there. Look up here. Just the empty set is the element, right? So if we go back up, it's union with the empty set. Where's my pen? Which is item 1, right? So the difference between this one and this one is here I'm unioning it with the empty set, right? Down here, I'm unioning it with another set that contains the empty set, so now suddenly the empty set is inside of my union. Okay, and let's take a look at this last one. The last one, right, we have A, and we're unioning it with a set that has, boy, it has A and B in a set, and also AB. So this ends up, when I take the union, right, this equals, well, let's see. We got to have that A from the first set and then everything from the second set. And remember that this A comma B is different, right? This is the set containing A and B, right? So this is a single thing that has two things in it. This is just an A by itself. So they're different. And so we're going to have A, comma, the set containing A and B, and then also AB. So when we start looking around for the numbers of these things, I think A is just 8, but let's look. Yep, so item 8 was A. And then we had, so let's put an 8 down. And then we had the set containing A and B, and that looks like it's over here at 15, right? So we'll write 15, and then we need the AB part, right? This part, which is item 13. Okay, on the previous page, we did questions about union. Now we're answering questions about intersection, right? So what is in the intersection of these two sets? And remember, intersection, something is in the intersection only if it's in both the first set and the second set. So I say, well, there's an A here, but there's no A here. And there's a B here, but there's no B here. And there's a C here. Oh, yay, there's a C over here. Okay, so the only elements of the intersection of these two is just a C. And so we go take a look in our little list and we say, look at that. C is item 10. And so we're going to put a 10 in there. Let's move back over and pen. Put in a 10. Okay, let's keep going. The next one is a bunch of things. All right, where's my lightsaber? Here we go. It's A, B, and C intersected with the empty set. Oh, hang on. Intersection means it's got to be in both sets. What's in the empty set? Nothing. So what does the intersection of these equal? Well, the intersection of these things equals the empty set, which is the same as, right? These are just two different ways of notation of these. And so I say, what are the elements of the empty set? Well, there's nothing in here, right? Nothing in there. So what we need to do when we look at our answers is we actually need to go all the way down to the bottom and we need to take the none of the above, right? So it's item 22 is what we're going to put in there. Pen 22. In here, we have an intersection, and indeed there is an empty set there, but there's some other stuff too, so let's take a look. Oh, and the empty set is inside of the braces, right? So we have A is in here, and it's also in there. So we know the first thing in our intersection is A. And B is in here, but there's no plain old B in here, right? C is in here, but no plain old C, right? There's BC, but that's different. That's the string BC, which is very different from a B and a C. And then inside of our bigger set, there is also the empty set. And look, it's over here too, the empty set. So the empty set is in fact in the intersection here. And that's pretty much it. So now we have to say the items that are in there. If we go look, are A in the empty set. So A is item 8. And the empty set is item 1. So our answer is going to be items 8 and 1. And if we look at this last one, it says intersect these things. So we get out our magic lightsaber, and A is in there, and A is also in there. So A is definitely in our intersection. B is in there, not in there. The last item that we have, the last element of this first set is A comma the empty set, right? Is there an element that's the set A comma the empty set in here? No. So the only thing that's in common between these is just the A. So this equals the set containing A, and I think that was 8, right? Look at that, it's item 8. So we're just going to write an 8 in there. Okay, a bunch of questions about alphabet, string, and language. We start out with just this thing A. We say, could it be an alphabet? Well, an alphabet is a set of strings. This is not a set, so no. Could it be a string? Absolutely. It's just, a string is 0 or more letters, that a finite number of letters that are squished together, contiguous, right? So that's a string. Could it be a language? Nope. A language is a set of strings, so definitely not a language because it's not a set. Again, in this second one, there's no set in here, so not an alphabet, not a language. Could it be a string? Well, we agreed in class that we were going to use the comma. Oops, that's supposed to be an arrow to the comma, not crossing out everything. But we agreed that we were going to use the comma as a special symbol that means something special. So because we're using the comma as a special symbol that means something special, commas can't be in strings. Therefore, this is not a string. Okay, moving on. Now we have a set, so that's something. All right, we have the set containing A. Could it be an alphabet? Absolutely. An alphabet is just a set of symbols, right? Finite set of symbols, so it's an alphabet. Could it be a string? No, because again, we agreed that curly braces are never symbols in our alphabet, so no. Could it be a language? Absolutely. I mean, A is a string as well as just being a single character or a symbol, and a language could have just one string in it, so yes. And let's look at the last one. Could D, here's D, be an alphabet? Well, an alphabet is a bunch of symbols, and we agreed in class that if we squish letters of the English alphabet together, that's not going to be individual symbols, that these things are all individual symbols, and this guy is actually 3 symbols squished together. So could it be an alphabet? No. Could it be a string? No, because it's got the curly braces, it's got the comma. But could it be a language? Sure. That's just a bunch of strings, right? Language is a set of strings. Yes. Okay, another multiple choicey thing. Select one language. I even tell you it's a set of strings from the list that describes the regular expression, right? So you're turning a regular expression into a string. And if we look at this first regular expression here, the parentheses actually are optional in this one, right? Because it just represents the string ABBA. And if we take a look at item 5 is, oh, AB comma BA. Item 6 is ABBA, right? So there you go. So the set containing one string, right? There's just that one string. So this one is going to be item 6. When we look at the AB star over here, right, that's, you have to have an A and then 0 or more B's after it. So now we got to look for something that has an A with B's after it. Where's my lightsaber? It's not item 7 because that is a bunch of A's and one B. But item 8 is promising. It has one A and then a bunch of B's. How many B's? Well, 0 or more. So yeah, I think that's item 8. Moving up a little bit. The next one says AB star. Where are you, lightsaber, right? So this is 0 or more occurrences of AB, right, squished together. So if we were to write this as a set and we were just listing out all the elements, we would probably do the empty set, and we're listing them in order of length, AB, and then we'd have AB, AB, and then we'd have AB, 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 sorry, and some dots to say and so on, right? So we're looking for something that has that sort of a pattern. And if we look around, it has to be repeating the A, B's. Look at, let's get a lightsaber here. Let's look at item 8. No, we just used it, but I didn't say you couldn't reuse it, but even so, there's always one A and a bunch of B's, but this one looks good, right? So item 9. And let's scroll up a little bit. Okay, so this next one, this guy looks very similar to this one, right? Except now it's 0 or more copies of ABAB, right? So it has to have either none or 2 or 4 or 6 or 8 and so on. And, you know, where are we? Oh, AB to the n plus 2, right? So, but n plus 2 would be, it's where n is element of the natural numbers. That would be like, you can't have 0, right? Because n could never be 0. Well, n is 0 here. That means that this n plus 2 is 2. And when n is 1, then n plus 2 is 2. So this is for like, is 3. So this is for like 2 of them, 3 of them, 4 of them, 5 of them, and so on. But this one, where I say, well, if n is 0, then we have 0 copies of this AB. If n is 1, then we have 2 copies of this AB, which is really ABAB, right? If n is 2, we have 4 copies of the AB. So yeah, it looks like item 11 is our choice. And the last one, lightsaber, A star, BB star, right? So that means 0 more A's, and then a B, and then 0 more B's, right? So that's what the strings in here look like. So, you know, when you start looking around here, I don't have anything that looks like this, right? That has A star, BB star. But if you think about it, a B followed by 0 or more B's is the same as 1 or more B's, right? So I'm guessing, oh, and it's A star. So it's going to be an A to the N in here, right? So we need an A to the N. And the B has to have one more than, it has to have at least 1. So we have to start one more than 0. And there's a couple things with m plus 1 here. And this one isn't right? Because here we have a to the n plus 1, which would mean a would have to start, see, n is an element of n. So n would have to start at 1, which is no good for a, because over here we have a star. But this one looks pretty good, right? So we have 0 or more a's followed by 1 or more b's. That looks good. So that's 16. So that's item 16. Okay, in this problem, we're going back the other way. We are starting with a set and turning it into a regular expression. So let's see, we're just starting with the union of 2 strings. So this is just the set that has 2 strings in it. So we got to find the language that has just these 2 strings, AB and ABB. And, oh, look at that one. If I multiply this out, right, I had to make it a little bit trickier. That's AB plus ABB, right? So where's my pen? This regular expression equals AB plus ABB, which is exactly the regular expression that represents this set, this language. So we're going to put in item 4 here. And let's see what's next. So now we have 2 sets. We have one that starts out here, right? That's all A's, and it looks like 1, 2, 3, and so on, right? So it's 0, 1, 2, 3. So this part's going to be A star, right? The second part, when we look at that, we have 0, 2, 4, 6. So this is going to be a BB star, right? So we got to look for something that looks like an A star, BB star. Nope. Nope. Aha. Item 7, right? Some semesters these questions are a little bit tricky, and you have to look at this list down here, and sometimes you need to think about, well, what else could that represent? Well, kind of like we did in here, right? But for this one, it wasn't too bad. And let's see, what else we got here? We have this next pattern. It's BB and then ABB. Oh, 2 A's. All right, so the A's are growing. So it always has 2 B's, and it looks like it's got A star in front of it, right? Oh, was that the one we saw? Yeah, here, look. That one is, ooh, that's not what I wanted to do. Sorry. I don't know if you see anything, but I was trying to get my lightsaber. But anyway, that looks like this, right? We have a 0 or more A's, always followed by 2 B's, which is exactly what we got here. So that's item 6. Pen 6. The next one, what's the pattern here? Where are you, lightsaber? 1A, 1B. Oh, look, AB, AB, ABB. 3 A's and a B, 2 A's and 2 B's, an A and 3 B's. It looks like it always has to start with an A, end with a B, but it could have either in between, right? So, when we think about this, it's going to be interesting because we need to start with an A. All right, so what I think I'm going to be looking for is it has to have an A and then A star, and then B star. But if you take a look at the answers, I think this one was the one I made kind of tricky. You don't see anything in here that is A star, B star, right? Now, we can get rid of a whole bunch of stuff because we know, like, these first ones, lightsaber, these don't have an A star at the beginning, so that does. But this one doesn't have more choices for B. And this one has to be even ones. So these first few don't look so good. And that's got A, B. Oh, no, that doesn't have the A star, though, right? We don't have enough A's. This one doesn't have the B star, right? But what's this thing? An A and then an A star. Lambda plus B. Oh, this could have 0 B's because it's got the lambda in there. But what about item 13? An A plus an A star. Huh. Oh, look, it ends with a, look at that. Tricky, tricky. Okay, so it's an A plus an A star. It ends with a B, and this whole yuck in here actually is the same as B star, right? Because if you've got B star in there, you could choose B star. You could also choose BB star, but B star is part of BB star, and you could also choose lambda, but that's part of B. So what we're looking for is you have to have an A, then as many A's as you want. This whole piece here, let me get a pen so I can circle it. This whole piece is actually, right, you have lambda or 1B or 2 B's and you star them. And if we didn't star them, it would just be 3 strings, including the empty string. But because we star it, you can take 0 more of any of these. So that means you can take 0 more B's, which gives us a B star. So this last one, oh, it's not the last one, sorry. But this one is going to be item 13. And let's just take a look at that last one. So we have A, B, A, B, B, A, 3 B's, A, 4 B's. All right, so a single A followed by, has to be, Lightsaber's hard. Okay, so have to have at least one A and one B. Always have one A, right? And we have an increasing number of B's. So let's move over and see if we can find this. It's not lightsaber, where are you? Not this one, right? Because it doesn't require any strings. This one, well, this one does require an A, and it does require a B. But the A's can also grow on this one. So we don't want anything with a star near the A. And we only want one A, so that one's out. But this one, let's see, we have one A, and then we have one B, and we have to have one of each. And then we have this hack that really means B star, right? So the answer is going to be that one. It's going to be, oops, sorry, see? You don't know behind the scenes how many of these things I have to keep switching tools so that I can put everything in and move around. But there you go. We got item 9. Okay, so here we're just practicing writing regular expressions. And we need the set of all strings over the alphabet A, B, C that start with A, B, C. So this one's easy, right? It starts with an A, a B, C. And then after that, you can have 0 or more of any of those letters. So A plus B plus C, and the whole thing starred. Let's go look at the next one. Has either an A or a B, right? Either A or B, but not both, right? And so of course I give you the examples again. So let's suppose here will be the strings that contain an A, here will be the strings that contain a B, and we'll sort of add them together. And the ones that contain an A have to have one A, right? But then they could have 0 or more A's and C's in front of and behind that A. So that'll be A plus C star A times A plus C star. That's a plus. Can you tell that's a plus? And on the other side, we can't have any A's, but we can have B's and C's. So B plus C star, B plus C star. So all of these strings are made up of just A's and C's, but they have at least one A. And all of these strings are made up of any B's and C's in any order, except there's got to be at least one B. Okay, and the last one, it has to be at least 2 letters long and start and end with the same letter and same alphabet. Okay, so start and end with the same letter. Oops, I lost my pen. So we're going to have like A, and then it could have an A or a B or a C. Oops, there's a plus in there. Star. And end with an A. So there's one example of a string. Plus, and I'm going to wrap around to the next line, B times any strings, any characters that you want in the middle, as long as I end with a B, plus C times anything in the middle again, starred, but it's got to end with a C. All right, so for this question, we have an NFA that's drawn in JFlap, and we have to describe it formally, and we're asked for different pieces. So here we go, see both sides. So 7A says, what is the states part of the 5-tuple? So the states is going to be a set, and I'm going to just do these in numeric order and then alphabetical order because I asked the online students to do that so that the test would grade it easily and nicely. So the states are 1 and 2 and 5 and 8 and foo. All right. And what's the alphabet part? Well, the alphabet is whatever's written on all the transitions, as long as there's no lambda, because you can't have lambda. Lambda's never part of an alphabet, right? But so what do we got? We got A, B, C, D, and W. And again, it's important that you put that in a set because I said important up here. Let's keep going. What should be written for the alphabet? Oh, I just did that, sorry. What should be written for the start? Well, the start is just 2, and that's not in set symbols because there's always just 1. What should be the final part? Well, the final part definitely has set symbols, and I see a 5 there. So 5 has a double circle. Let's just scroll down a little bit. Oh, 1, 2, 8, 5. So let's see, 5, 1, oops, pen, 1, 2, and 8. And if you were in the online section and you actually wrote the numbers in the wrong order, but your answer is correct, you can just say to me, oh, I spaced and put them in the wrong order, but my answer is correct. So could you give me credit again? Okay, so over here, all right, I said you see the rows labeled. Where's lightsaber? There we go. So we have a row for 1 and a row for 2. What other rows do we need? And the answer is we need a row for every single state. So we have 5, 8, and foo. So let's go down and do that. Sorry, move, not cross out. So we were missing 5, 8, and foo. And it says what other columns are missing. And in here, you've got A, B, and you can, where's the lightsaber? You can kind of sort of see C. And so what are the other columns? The other columns are any other symbols that we might have transitions for. So we have A, B, C. So we got to add D. We got to add W. And remember that in terms of, here, let me move this up. So what other columns are missing? Well, our chart definitely gets D. It definitely gets W. And then as I was starting to say, you have to remember that you always do a column if you have an NFA for lambda. So we have to add a column for lambda. And then we're just asked to fill in the boxes on the right. So we kind of go over and we look and we say, all right, 1 on A and 1 on B. Let's take a look. So if I'm at 1 and I see an A, I go nowhere. If I'm at 1 and I see a B, I go nowhere. So both of those guys are going to just be the empty set, right? If I am at 2, come on, there we go, lightsaber. I see the A, I can go to 8, and that's it. And if I see 2 and I see the B, I could go to 1 or foo. So let's see if we can remember that as we move down. So 2 on an A, we said could only go to 8. So, but because we're writing an NFA, and this has to be a function, we can't just write an 8 there. Everything has to be a set. And I forgot, what did we say? So 2 on B goes to 1 and foo. So in here, we'll make a set that goes to 1 and foo. And I think that was it for this question, right? Yep. Cool. So these questions are asking you, are these things DFAs and are they NFAs? And I intentionally made them so that you would sort of look back and forth between them so you could understand what's the difference between these ones, right? And the big difference is that the start symbol is here, so Q0 is the start state for this one, and I can't do the lightsaber quite that low down. Lightsaber. And the start symbol is here on Q1 for this other one, right? But, you know, is it a DFA? Are they DFAs? Well, if we look at this first one, does it have a start? Yes. Does it have, where's lightsaber? Does it have a start? It has a start state. Does it have any except states? Well, it doesn't have to, but it does. And then besides that, it's got states and transitions. Does it have an out transition for every letter of the alphabet from every state? Well, if you're at Q0, it's got out transition for A and for B. If you're at Q1, for A and for B. So, looks good. It is, yes, it's a DFA. And if it's a DFA, automatically an NFA. Don't even have to think. For this second one, it's a little bit confusing to people because nothing gets accepted, right? So you have to get over to here to be accepted, and there's nothing between them. But there's no rules that say you have to have something between them. You just have to have an A and a B out for both of these, which we do. And so, I mean, if you look at this DFA just accepts the empty set, right? But that's okay. You're allowed to have the empty language, right? So is it a DFA? Well, it's got an out transition for every letter of the alphabet, just one of them from each state. So yeah. And so it's also an NFA, right? Okay, same kind of problems again. And if you look, it's got a start state. It looks very nice, but if we find our lightsaber, here we go. From Q0, there's an out with A here, and there's also a loop on A, and that is not allowed in a DFA. So is it a DFA? No. But there's nothing wrong with this as an NFA, so sure. Right? And let's scooch up to the last one. And the last one, well, there's a giveaway if ever you wanted it. There's a lambda transition in there. So for sure, it is not a DFA. In terms of NFAs, it has a start state. It's got a bunch of states and transitions. They're over the alphabet that we said, right? Over the alphabet AB. Yeah, looks good. Okay, for these problems, we got to turn an NFA into a regular expression. And the important thing here is to just keep track of where all of the accept states are, right? So looks like we've got an accept state at Q0, an accept state at Q1, and this accept state at Q3. So because there's an accept state at Q0, we know that this language includes lambda. And the only way to get to Q1 is just by taking this B transition, right? So, and then you accept. So lambda plus B, that's something, right? And now we got to look with our lightsaber, so we don't mess stuff anymore, at all this other junk and see what's going on, right? How do you get to the last accept state, Q3? Well, one way to get there is you do a B and then a lambda jump, as many D's as you want, and then an A, right? So that would be, what did I say? You do a B, then a lambda jump. We don't have to write that down. And then as many D's as you want, and then an A. And then there's one more way to get there, which is to take this, oops, sorry. Where are we? Here we go. I was looking for the lightsaber, which is to take this upper loop, in which case, oh, no, you can't see it. You have to have an A, as many B's as you want, a C, as many D's as you want, and then another A. So we have A, B star, C, D star, A. And I think that gives us everything we need. Let's look at the second one. Okay, so on the second one, again, we're just trying to see, like, what are the paths to the accept state, and Q1 is our only accept state. So we start at Q0, and we can either go A, or we could go a CC. And then after that, we can take as many, we can add as many B's as you want, right? So we could write this by saying, all right, well, I'm going to start with an A or a CC. And then I'll have 0 or more B's. So B star. And that looks pretty good. I mean, you could also write it out. There's nothing wrong, and I gave totally full credit for A B star plus CC B star. Or even some people also added to this an A and a CC, and that's fine too, right? These guys are not necessary, but it's okay to put them there because CC, this CC is actually part of that, and this A is actually part of that. Okay, so now we got to draw an NFA that accepts the language, oops, sorry, ABC star D plus BC star D. So let's make one, oops, that's a 1, our start state. And we have to have either a bunch of ABCs or a bunch of BCs, but we can't let them interact with each other, right? So let me show you first what some people did that's wrong, okay, which is that they said, all right, well, I could have a B and then a C, or I could have an A, oops, and then a B, we'll make this one 3, and then a C, right? And then I'll have a D at the end, 1, 2, 3, 4, 5, right? But that's no good because this says either it starts with ABCs like ABC, 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 or BC, 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 but you can't mix them up. And in this diagram that we've drawn, I can mix them up because I could like do the BC root the first time and then the ABC root the second time and so on. So that's no good. This one doesn't work. So we need to try again, and I need to figure out how to cut all this stuff. So hang on. Okay, I got rid of it. So what we need is we need to have two distinct paths for that, right? So one way to do that is to say, here's my start. Here's state 1. And I'll have A, B, C, and I'll actually add in an extra state here. And then as many A's as I want, right? Or I can go with a D to make the state 5, which is an accept state. So that lets me have as many, you see the path that I can go on here now, right? So I can do A, B, C, A, B, C, A, B, C, A, B, C as many times as I want, and then I go to D. Or I could have BC star D, so that would be a B. And what do we got? 2, 6. And then a C, which will be 7. And then we could have more of those BCs if we want, or we could just have the D to go back there. And then the only last thing we need to look at is, can we get just a D, right? Because if I look at this language up here, we could have just a D. And the way I drew this, there is no just D. So I'm going to go like this and get myself a D. Now, some people started out with lambda transitions, and that's perfectly fine too. You can sort of lambda out this way and lambda out this way to do your BC, 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 or your ABC, ABC, ABC. And then you can have the D transition be in there. I guess I could show you that too. Why not? Hang on. So there's an infinite number of solutions to this, right? But the other common way to do this would be the following. Whenever you have a plus, you can always think of it as, okay, I could just do 2. If you're doing an NFA, I could do 2 lambda transitions. So now you could do 2, 3. We could do A, B, C like that, and D comes out of 2, or 1, 2, 3, 4, 5, 6, 7, which would be just the BCs with a D over there. Now you can't, because of these initial lambda transitions, you can't go back. So you can't do the BCs and then some ABCs and then some BCs. But as an added bonus, I can take a lambda transition and a D there, or this lambda transition and D there. So the D by itself is already built in. Okay, last one. Oops, make it bigger. Sorry, last 2. Is we have to do a proof. And when you are doing a proof, right, you absolutely have to do it in the Dr. K style, because I made a big deal of that in lecture and in the slides. So if I tell you to prove this stuff, then you either got to start with this on the left-hand side and end up with that on the right-hand side, or vice versa. And please do not start out by saying they're equal. The whole point is you're showing me they're equal. You're proving that they're equal. So let's just do it from left to right. I'm not going to show you my scratch work. I'll just show you my final solution. So I need to start. I said I'm going to do from left to right, so I need to start by copying this. I'm going to write A, B star plus C times D plus E star equals, I'm going to change colors of pens just because I think that the green is kind of hard to see. There's no other reason for it. So what does that equal? Well, the first thing I'm going to do is I'm going to, I'm assuming, by the way, that you have the sheet with all of the rules that we use. I'll leave that at the very end of this exam, since it's on page 16 of this exam. But but I'm assuming you have our rules in front of you. If you're watching this video, just pull out the sheet with all the rules on it. So I'm going to do the standard thing that I always do whenever I can, which is distribute this out first. So I'm going to say that is equal to, I'll put an extra set of equals here and I won't put them there. I'll say that equals AB star plus CD plus CE star. And that is by distributed 3.1. And I told you have to give me the R's and S's and T's, so where this should all really be on one line, but writing it on a tablet is a major pain, so you're just going to have to deal with me. Where R equals, let's see, R is just the C part, and S is the D, and T is the, I can move over slightly. There we go. T is going to be my EE star. Maybe I'll keep changing colors just so that you can see what every line is, given that it's so hard for me to write small on the tablet. Okay, so the next thing that I'm going to do is I'm going to notice, well, I notice that I have E star E here and EE star here. So I'm going to use closure 6 to just move that around. So I'm going to say that equals, where's my pen? That equals, and again, I'm just changing pen colors to make it clear which is each line because it's really messy on this tablet. So that equals, let me copy everything again, AB star plus CD plus C, and now we have E star E. And that is by closure 6, where R equals E. Notice that R does not equal E star. If you look at the rule for closure 6, R is just E. So let's go back to the green pen. And now what I'm going to do is I'm going to use closure 5.2 to turn this B star into lambda plus B star. So I'm going to say that equals A times lambda plus B star plus CD plus CE star E. And that was by closure 5.2. Come on, give me a point. Closure 5.2, where R is equal to B. Again, R is just B. And let's move up a little bit so we have a little more space. And get a blue pen. And now, of course, I'm going to use my distribute 3.1 again to multiply that out. So I get that equals A times lambda plus A times B star plus CD plus C E star E. And that's by distributed 3.1, where R equals A, S is lambda, and T is B star. Okay. And now we're almost at the solution. Remember what we're trying to get to. We're trying to equal AB star, right? Well, we have the AB star part, right? Oh, sorry. We're trying to get to be A plus AB star. Where's my, here we go. A plus AB star, well, we got that, except we got this A lambda, but we can deal with that, plus CE star E. We got the CE star E and the CD. So we're getting pretty close. I guess we need to swap these two, and we can do that using plus 1.1. So let's do that next. What color am I on? Red. Equals, oops, I don't want green or red. Equals, there we go. So we're swapping the last two using plus 1.1, right? A lambda plus AB star plus CE star E plus CD, and that is just by plus 1.1, where R equals CD and T equals CE star E. And now we have almost the entire answer. We just need to change, we've got to get rid of this A lambda, turn it into an A, but we can do that with dot 2.2. So we're up to green. So we'll say that equals A plus AB star plus CE star E plus CD, and that's dot 2.2 where R equals A. And now look, we have a proof. We started with the, where are you, lightsaber? We started with the left-hand side. We get to the bottom and we have equal something that is in fact the right-hand side of our equation. And so now all we got to do is write Q, E, D. And we're done. So I will shrink the page just a little bit so you can see my whole proof. And I'll leave it there for a second so you can just absorb it and see how wonderful it is. And then we'll just look at the last problem. Okay, so last problem, another proof. Again, when you want to do a proof, you either need to start with the stuff on the left and make it equal to the stuff on the right, or you could start with the stuff on the right and show that it's equal to the stuff on the left. I think it's easier to start on the left with this one too, so I'm just going to do that. So we're going to start with A, F, D star, oops, there's parentheses there, plus B, C star, plus A star, B, C star. We're not going to write equals this stuff on the right at the top because that's what we're trying to prove, right? So we will say equals, and the first thing I'm going to do, I can do a distributed 3.1 here. I'm going to do it. So I'm going to say equals A, F, D star, plus A, B, C star. Need to shrink this just a little bit. Plus that last term, A star, B, C star, and the reasons for that is, of course, distributed 3.1, where R is A and S was the FD star, and T was the BC star. Right? I guess I am changing colors because it's too hard. They all merge into one. All right. And now what I'm going to notice is, look at that. There's a BC star on there and a BC star on there. Right? So I'm going to pull that out using distributed 3.2. That's going to equal AFD star. And by the way, I also noticed that I have the AFD star at the beginning, which is what I'm trying to get to. So AFD star plus, and then we got A plus A star times BC star, right? And let's just move up a tiny bit. And so that is using distributed 3.2, where R is the BC star, right? And S is A and T is A star, okay? And now let's take a look and see what we got. So if we look at what we have and where we're going, I need my lightsaber. There we go. We have the AFD star here, which is the start of this thing. And we need to turn this A plus A star BC star into a plain old A star B C star, right? Well, I remember there's a rule that can turn an R star into R star, and I look it up. It looks like it's closure 5.1, so let's do that. I'll change colors in the pen. And I will slide us up slightly. There we go. Go back to my pen. So this whole thing equals AFD star plus A star BC star C star. And that was by closure 5.1, where my R is just a C. Okay. And now I know that A is inside of A star, so I know A plus A star must equal A star. I just need to find the rule for it. And I'm looking on my sheet, and hang on. Oh, look at that. It's another closure 5.1. It's just my R is going to be different. So now I'm going to say that whole thing equals AFD star plus A star times BC star C star. And that's also going to be by closure 5.1. But this time R is going to be A. Oops, that's capital R. And now we're all done, right? Because if I show you up at the top, we have AFD star. I'll shrink it a bit. All right. I was trying to get to AFD star plus A star BC star C star. And I have AFD star plus A star BC star C star. Therefore, I can write QED. Therefore, I'm done. Okay, and I'm just going to let the video this page for a couple of seconds so you can see the reasons that I use, just in case you don't happen to have my reason sheet.